Alright, in this video I am going to give an introduction to hyperbolas, and that means I am just going to be going over the properties of hyperbolas. Now the graphs that I'm going to draw are generic graphs. They are not ones that would get you points in class, but they are ones that will give you a visual so you can see everything that I'm talking about. Alright, it's something to point at. So this is like graphs for notes. Okay? Now, first of all, if I want to write an equation for a horizontal hyperbola, I am going to put x squared over a squared, okay, minus y squared over b squared equals 1. And then the equation for a vertical hyperbola is y squared over a squared minus x squared over b squared equals 1. Now, notice the difference in the two equations. Right. The x squared is doing the subtracting, and the y squared is being subtracted. The y squared is doing the subtracting in the vertical, and the x squared is being subtracted. You notice the a squareds and the b squareds do not change position. Okay? They do not change position. Alright, so let's go over some generic parts. Okay, in our, let's see, the major axis in a hyperbola is not called major axis. It's called a transverse axis. Okay? So the transverse axis is horizontal. How do I know? Because the horizontal coordinate x is the one doing the subtracting, and the vertical coordinate y is the one being subtracted. Here, in a vertical hyperbola, the transverse axis is vertical. Why? Because the y-coordinate, the vertical coordinate, is the one doing the subtracting, and the x-coordinate, the horizontal coordinate, is being subtracted. So, my vertices for the horizontal are at the coordinates plus or minus a, comma, 0. Okay, my vertices for a vertical hyperbola are at the coordinates 0, comma, plus or minus a. Okay, so I'm going to put those points on here. I'm just going to say this distance is a in the negative direction, and roughly the same distance is a in the positive. So here's a, and here's negative a. Okay, now in ellipses we had a major axis and a minor axis. Well, in hyperbolas I have a transverse axis, and the other axis, what would have been a minor axis if we were looking at an ellipse, is called a conjugate axis. Okay, conjugate axis is related to B. Okay, now B is my vertical coordinate on a horizontal hyperbola. So if this is going to be, we'll just say this is B, it really, B could actually even be larger than A. Okay, yeah, that doesn't matter. What matters is what's being subtracted and what's doing the subtracting. Okay, so this is B, and this is negative B. Okay, and let me put both A and B on my vertical. So this is going to be A, and it does not matter which one is larger, so I might make A smaller than B on this one. So here is A, here is negative A, here is B. You notice that I made a larger distance. And here is negative B. Okay. Now, you have on hyperbolas asymptotes. Okay. The asymptotes are this. It is the equation y equals plus or minus b over a times x. Now, for a vertical, since a is a vertical coordinate, you know slope is rise over run. That's where we get this, rise over run. See? Up b units over a units. Okay? Up a units for a vertical hyperbola and over b units. So my asymptotes would be the line y equals plus or minus a over b times x. Now, I'm going to show you an easy way of doing this. Yeah, you could do your rise and run, you graph your asymptotes. That's true. Here's an easy way of getting your asymptotes, and really all it is using the rise over the run. Okay? On the horizontal hyperbola, I counted up b units and over a units, and then what I'm going to do, I'm just going to change colors on this so you can see it. This is not part of the graph itself. Maybe I'll do orange. Okay, and I am just going to make this little box. What I did is I went up b units over a units, and I am just going to make this nice little box. Okay, okay. Now I'm going to do the same thing. I'll put my little box over here. All right. This orange really is not part of the graph. Okay. It's this little box, though, does help in graphing this. Well, a little beyond there, we just have to know where the corners of our box is. Because, see, the corners of the box is really like your rise and your run, getting your asymptotes. So all I have to do are connect the diagonal corners of the box, and I have my asymptotes. So let me get another color here for my asymptotes. I'll use green, okay? Now, it always helps if you use a ruler, and I am not very good with the ruler tool on this. Okay, yeah, it should go through the center. And connect here. Okay, I'm going to put my asymptotes on the other one, on the vertical one. Let's see. Might be easier if I start going with them from the origin. Okay. That's okay, I'm going through there. Now, the easiest way of drawing your hyperbola, ride right along the asymptotes and you will touch where A is. Okay? So let me go back to my purple because that's going to be part of my graph. So horizontal, I'm just going to horizontally, I ride right along the asymptotes. It touches at A. Curves, because that's the vertex. Okay? Yeah. And ride right along the asymptotes. You notice I didn't have to get a bunch of points. Touches at A. Curves, rides right along those asymptotes. Okay, for the vertical one, same thing. Rides right along my asymptotes. Touches at A. Curves, goes up. And then rides right along the asymptote. Touches at A. Curves. And goes back down, rides along that asymptote. I was a little bad on that one. That one wasn't as good. I'm a little better at drawing the horizontal ones, I guess, than the vertical. All right, now, what we need to find are the foci. Okay? Now, your foci for the horizontal are at plus or minus C, comma, 0. And for the vertical, foci are at 0, comma, plus or minus C. Now, we're going to actually use the Pythagorean Theorem. So, C squared equals A squared plus B squared. Okay? Same thing here. C squared equals A squared plus B squared. So, C would be in there somewhere. That would be positive C, and that would be negative C. All right? And it's always where the vertex is, nearer the vertex, C. So this is positive C, and somewhere in here would be like your negative C. All righty. Now, you notice this distance from A to A there. This is A units, so my transverse axis is 2A units. So I'm going to put 2A units. For this one, it's still 2A. Okay, the conjugate axis, and here, let me write that on here. C-O-N. It's 2B units. Same thing. I mean, it doesn't change because, see, A is always associated with the transverse axis. B is always associated with the conjugate axis. So it's the same thing with the vertical. It's 2B units. Okay, so that means that this distance is 2B. To be or not to be? That is the question. Oh, sorry, I didn't mean to confuse it with Shakespeare. All right, well, have fun working on these. Enjoy, enjoy, enjoy. And remember, to be are parabolas. Or, if we want the transverse axis, 2A. Have a good day.